Hello, Year 10. How are you? I hope you're all well and that you enjoyed your week off and that you rested and relaxed and enjoyed the nice weather and spent time with your family and everything. So I hope you're all well. So today we continue through our exploration of different 3D shapes, and we start with just a little recap of a volume of a cone. So here's the formula again for the volume of a cone. This one here. Volume is a third pi r squared multiplied by the height, which would be that there, and r being your radius of the bottom of the cone. So this kind of illustrates how it works. You've got your cone that fits into a cylinder, and really the volume of that cone is equal to a third of the volume of the cylinder. That's what that means. That's where the third comes from. That's why if you removed the third, your formula would just be pi r squared times h, which is the formula for the volume of a cylinder. So that's kind of the explanation behind that. Here's your starter for today then. So I want you to find the volume of this cone and give your answer to one decimal place for your starter. Okay, so pause the video, have a go at that before we move on to the surface area of a cylinder. So pause your video, do this now, get your answers down, and then move on and press play. So here we go, here's your title and your date, your volume and surface area of cones. And to learn how to find, well, we've done the volume, that's all good, we've done that before, and the surface area of a cone, that's what we need to do next. Okay, so pause the video, write your title and your date down, and we'll get going. So here's the surface area. Now, there are two faces to a cone. You've got that curved face around the cylinder, and then you've got the circular face at the bottom. Okay, so the curved face and then the circular face at the bottom. And what you need, the two lengths you need to find the surface area of a cone, you need the slanted height, which is given as L, and you need the radius of the base of the cone. So they're the two things that you need. Now the curved surface area of the cone, where you've got your length and you've got pi times r, that here, this formula is just for the curved face of a cone. Now the total would obviously be this plus your area of the circle, which is pi r squared. So here's your formula here that I'd like you to copy down into your books. You can do both actually and highlight both so you know what the curved surface area of the cone is and then the full surface area of the cone with the area of the base attached to it. L is the slanted height, not the vertical height. You don't need that vertical height to find the surface area. You might be given it. And you can think about that for a second. What would you do if you were given that height instead of L? What would you have to do? We will cover that at some point. So here's your first example. Find the total surface area of the cone below. Leave your answers in terms of pi. Lovely. So the surface area of the cone is pi RL plus pi r squared. So if we just highlight, if I go through and highlight the two lengths that we need, we don't need the 8 centimetres. Don't need it. That's a little red herring thrown in there for you. But as we can see, it's actually a right angle triangle that's created there. You've got 8 centimetres, 6 centimetres and 10 centimetres. And that there, for those of you that have recognised that, that is a Pythagorean triple. So you can see what you would have to do there if you were given the perpendicular height and not the slanted height. You would need to use Pythagoras. Thankfully for this one, we don't need to do that. So let's have a look. Your surface area, we can literally just plug those values in. Pi RL plus pi r squared. So we've got pi, r is 6, pi times 6 times by 10 plus pi times 6 squared. Remember, we're doing this without a calculator, so we would have 60 pi plus 36 pi, and we can add them together because they're both in terms of pi. So we get 96 pi centimetres squared. Done. And that's the total surface area of that cone in terms of pi centimetres squared. Now, if one of those didn't have a pi, say the 60 didn't have a pi, or the 36 didn't have a pi, you wouldn't be able to collect them together. So just bear that in mind. Okay, here are some that I want you to have a go at. So pause your video, have a go at these, and then I will show you the answers to them. If you cheat, you're only cheating yourself, okay? So pause the video, have a go at finding the surface area of these. Now be careful here because this is exactly what I talked about here. You're given your radius, which is 8, but you're not given that slanted height. But look, I've been very kind here, and these two lengths here are the same as this one here. Okay, except the height, they might be the other way around. Okay, but you can find that slanted height there using Pythagoras before you go any further. So pause the video, have a go. Hope you've done that now. Here I'm going to reveal the answers. So here we've got your slanted length is 12 and your radius is 4. You add those together and you get 64 pi centimetres squared, which if I do to 1 decimal place is 201.1. Okay, 201.1 centimetres squared. Let me just write that in. 201.1 centimetres squared to 1 decimal place. Let's have a look at the other one. We needed to find that slanted height using Pythagoras. So that slanted height was 10 because we've got Pythagorean triple there. Your slanted height therefore is 10 and your radius is 8. Again, your area of your circle is 64 pi centimetres squared and your curved edge is 80 pi. Adding those together, 144 pi centimetres squared, which if I change would be 452.4. 452.4 centimetres squared. Okay, to 1 decimal place. So pause the video if you need to go through that working out there. Obviously the working out that I did here was much more kind of precise. So you can, of course, do it that way. I'm just showing you the different kind of breakdowns. Okay, here are the questions I'd like you to do for today. So you've got question 1. I want you to give your answer to the surface area for each of these in terms of pi for question 1. And then question 2 is to 1 decimal place. Remember which lengths you need. So, as usual, please submit a picture of your work to me as soon as you've completed it. I'm here to help you throughout the day, so please send me any messages. Even if I'm not at home, even if I've, popped out for a walk or whatever, I've got my phone with me so I can reply to you from my phone. So it's so easy for me to do. So please don't sit there worrying about anything. Please email me. Answers to be posted later because we know that some people like to cheat. Okay, and I look forward to seeing your work, Year 10. And I hope that seems a little bit straightforward for everyone. And I really do hope you're all well and safe.